Hi everybody. What we're going to do today, as Adam had stated, is go over our industrial pipe clamps. This is kind of a basic product training, kind of discussing all the different available options of the product line, and then we're going to go into some details about sizing and selection, and then some loosely detailed applications, specific industries where our product can be used. And it should kind of help you pick out, size, select, and apply our pipe clamps for any application that you'll come across in the field. So, as I had mentioned, our agenda is a little bit. First, we're going to go over Behringer's capabilities. It's something I think everyone should know, especially in our pipe clamp range. We have a lot of capabilities for custom products, and we have the ability to custom tailor our existing products to fit specific applications that you might have, and we're very flexible with the things that we can do. Then we'll go over the details of the product, sizing, selection, and application of our product, and then we'll go over some industry applications where our products are used, and then we'll touch briefly on specifics within each industry where the clamps could be used. So Behringer Company was founded in 1869 in Newark, New Jersey. It was just a metalworking facility at that time, manufacturing parts out of steel for industrial customers such as Mack Truck and Otis Elevator. At one time, Behringer Metalworks made over 800 different parts for Mack Truck, and to this day we still retain the Otis Elevator customer. We build parts for an OEM that makes sub-assembly components that end up in the Otis Elevator systems. And the original Behringer, back in the 1800s, who founded the company, actually holds some patents in the U.S. Patent Office that he shares with Thomas Edison. So that's kind of just a little interesting history point about Behringer. And we'll kind of touch on our capabilities. We're in Branchville, New Jersey, which is kind of, as you can see from the picture there, nestled in the mountain regions of northern New Jersey. We've got a 40,000 square foot manufacturing facility. We do complete metal and plastics processing here in-house. We manufacture all of our custom and current products here in Branchville, New Jersey now. We've got a number of equipment, and I'm not going to go into too much detail about it, but for processing, we can cut and shear steel. We've got a hydraulic brake so we can form it and bend it. We've got a full welding facility, automatic saws, water jet cutting machines. We've got a number of different presses ranging from 300 to 200 tons. We've got drill presses and lathes, bandsaws, a full machine shop. We do all of our in-house tool and die manufacturing and maintenance, and all of our engineering and design and manufacturing. In addition to our manufacturing capabilities, we've got a very extensive inventory. From the pictures that you can see here on the shelves, everything you see in boxes is our inventory on injection molded plastic parts. You'll see a little bit later, we'll go over the details of the parts, but and then below every stack there, you've got bins running all around the floor, and you can see kind of a close-up on the right-hand side of the bins where we're stocking all of our metal components. We've got all of our cover plates, weld plates, and bolts, and all that kind of stuff. So we've got a pretty extensive inventory on everything. Most of our normal off-the-shelf standard heavy series and twin series clamps, we've got a few thousand of each in stock of each size. So we can kind of accommodate just about any order within a very short period of time. Small orders, we've got same-day shipping. We can ship it out immediately. Larger orders that would have to ship truck, we ask for 3 to 5 days, and we're flexible on that. If anyone had any questions at that point, you can either type them in or raise your hand. I'm not going to pause too long on these question slides, but we're going to keep moving here. I know it's early, so we'll keep everything going for you guys. The product overview is the next section that I'm going to go over, and then this will kind of touch on the clamp product range. Our clamps are primarily used for pipes, tubes, and hoses in the hydraulic industry. That's the most popular application for our clamps. They can be used on electrical wire. They can be used on any type of plumbing, PVC piping. We have people who have used them in their homes for their wastewater drain lines or copper tubing or anything like that. So anywhere, we just had a recent application where a customer was using them. He's converting over his garage, actually. He collects dinosaur bones, and he's got an industrial theme going on, so he's using them for all his piping in his garage. They can be used anywhere to hold any type of pipe or tubing. Excuse me. But the most common, as I said, is hydraulics because of the shock and vibration in a hydraulic system or any type of pressure system. The clamps have natural anti-vibration or vibration dampening characteristics due to the ribs and the way that they're designed. They incorporate a modular insert design, is what we're saying here. If you look, what we mean by that is you have a clamp, and that we have what we call a group size, where you would have the same cover plate, the same bottom plate, bolts, and actually the plastic would be very similar. The only difference is the ID. So that would be, we can fit multiple different IDs in one group size, and we'll go over that a little bit later. The range of our pipe clamps range from our smallest size, which is 1/4 inch, up through 30-inch OD, which is quite large. A little bit more about our inserts or our clamp halves or clamp pairs. They're oval in shape, and if you look at the right, there's kind of an exaggerated caricature of the clamp halves. When they're spaced apart a little bit, and you can see that here, there's this space in between. You have a perfect circle for your diameter. That diameter is exactly what size you would need, and then as you tighten the clamp down and take up this little gap in here, you actually create the clamping force that holds the pipe in position. If you look at this exaggerated drawing, when you actually put the two clamp halves together, it's an oval shape, so it's not an actual perfect circle. The inside of our clamps have ribs, as I mentioned earlier. These ribs help to anchor the pipe or tube or hose and hold it in place and reduce vibration and any noise that are born into your system. The material of that clamp pair, there's 3 main materials that we offer, and the most common is going to be the top one that you see there, which is a black color. That's polypropylene material. You can see the temperature range here. We say up to 194 degrees continuous operating. These are continuous operating temperatures that you can operate at all day without any type of problem. There's also peak operating temperatures. Polypropylene, a maximum brief exposure to 212 degrees. We don't, I don't have that listed here. We tend to try to stay away from that. That's kind of just a rule of thumb for brief exposure. From time to time, it can reach those higher temperatures. The Sanaprene, which you'll see is the next one, it's beige in color. It's very similar in thermal characteristics to some of our competitors that use a polyamide material. We went with a Sanaprene. It's a thermoplastic rubber. It's a little bit softer, and it's more widely used in the automotive industry. Sanaprene carries approvals from GM, from Chrysler, from Ford, from all the big motor companies, and it's kind of worldwide acceptance into the automotive and excuse me, high temperature industry. There's a reason that we chose the Sanaprene. You can see the temperatures there to 275 degrees continuous, so it's used a lot in even process piping, steam lines, things like that. And then again, it has brief exposure up to 302 degrees, which is not listed here. For even higher temperatures, then of course we have aluminum material. Aluminum is good to 500 degrees continuous, and it's actually probably rated a lot higher than that, but this is our published maximum temperature. we say a brief exposure to 750 degrees. So for any real high temperature applications, steel mills and things like that, and we'll kind of go over that in the industry applications later, you would use an aluminum material. The hardware material, we call all of the supporting plates, bolts, everything, we call that the hardware. Hardware for each clamp is available in different materials. We've got a carbon, or just untreated steel, plain carbon steel. Zinc-plated steel is kind of a standard in all of our series except the heavy series. The heavy series typically comes in carbon or untreated steel. We'll go over that a little bit more later also. And then all of our clamps are available in 304 stainless steel or 316 stainless steel as options. 304 is quite commonly stocked on a lot of standard series and twin series and some of the heavy series. 316 is kind of touch and go, different specific sizes we have some stock on, some larger sizes in the heavy series, and then 316 would normally not be a stock item. And then we can do other materials on request, so if you need specific coatings or platings or something different, it's not a problem. Threads, all of our threads of our bolts, of our weld plates, of our rail nuts and things like that are typically UNC thread. We can do metric thread. We've got a lot of metric threaded nuts in stock to make our weld plates and for our unistrut nuts and our rail nuts. So we can rather quickly make those with metric thread if your customer requires that. Here I just want to show a typical assembly of a pipe clamp. This is your run-of-the-mill average everyday pipe clamp that most people are talking about. This is a weld-mounted clamp. If you look at the bottom here, this is your weld plate. The weld plate typically gets tack welded down, and then your clamp would be mounted on top of that. You see the clamp pair in the center there, and then the rest of your supporting hardware, you've got a cover plate and hex bolts that hold it together. So we've got a lot of different varieties and combinations and things that you can do, and I'll go over a lot of them in a little bit, over all the different mounting configurations. So what I want to do is go over the important things that you're going to need first in order to select a pipe clamp. This is if you're out in the field and you need something to secure a pipe, or a customer calls and they're out in the field and they need something to secure a pipe, hose or tube. This is kind of the checklist of things that you'll have to run down in order to be able to properly select a clamp. You're going to need to know what the application is. That'll tell you what series of clamp that you're going to use, whether it's a standard series or a heavy series. If you need a twin series, and we'll kind of go over all the series too also and give you the specifics of each series. You're going to need to know the outside diameter, and we'll go over each of these steps in a little bit more detail. The outside diameter is going to be important, obviously, to know what size of clamp you need. And there's a difference between a pipe size and a tube size and a hose size. So a lot of times we'll get a person requesting a 1-inch pipe clamp. That's for a 1-inch pipe, which would have a 1.315 OD. Sometimes people will call and say, I just need a 1-inch clamp. They don't tell you if it's a pipe size or tube size. So we'll go over that a little bit more detail. The mounting configuration, we're going to show all the mounting configurations that are available. You'll need to know how they want to mount it. And the threads, this is really only an issue. Usually our bolts engage with our weld plate or our rail nut or something like that. So really the threads become an issue depending on what kind of wrench the guy has. If he has all metric wrenches, then he wants a metric threaded bolt. That's where it would matter to an installer. If it's a piece of equipment that they're building that's going overseas, they might only want metric on it. And then the last thing you need to take into consideration is any type of environmental factors or requirements. And we'll go over that in a little bit more detail too. Things like if it's outside or if it's near salt water. So first we'll go over the application or series. Here you can see the main series of pipe clamps that we offer. The standard series pipe clamps, then we've got a heavy series, which is a little bit heavier duty, a twin series, which allows two lines to be right next to each other, a heavy 4 series, which is a patented design. The heavy 4 series is for larger sizes of pipe. A saddle series, which is more for low pressure process type in industrial applications, and our cushion clamp line, which is basically mounted to a unistrut. They're lower pressure, and they're used a lot in refrigeration, copper tubings, things like that, conduits and things like electrical. So we'll go over each of these series and tell you the main differences between all of them so that you can make an educated decision about which series you'll need. First we'll go over the standard series. Our standard series pipe clamps range from 1/4 inch through 4.5 inch OD. We give it a pressure rating. We say pressure is up to 2,000 psi, and I want to explain this a little bit. The pressure rating, what that means is we rate that any system operating up to 2,000 psi, our clamp can withstand whatever shock and vibration that system can deliver. The pressure rating is for a worst case scenario. If, for example, you have a system operating at 5,000 psi, but it's a very static system, there's not a lot of cylinders, there's not a lot of movement, the fluid kind of flows, and there's no vibration, you would be able to use a standard series pipe clamp. So this is kind of just a general rule of thumb. There's other instances where you might have something operating at, say, 5,000 psi, and there's no shock or vibration or anything like that, but it's on a piece of heavy-duty equipment or a piece of mining equipment. Then again, you would want to use a heavy series pipe clamp because it may have impact with a mine wall or some other type of equipment or anything like that. So even low pressure applications, you may want to use a heavy series pipe clamp for something like that. If there's going to be a lot of impact or a lot of vibration if it's inside an engine compartment or something like that. The mounting configurations for our standard series that are available are a weld plate, which is the most common. That's the one that we showed that gets welded down. There's we call it a base plate or a bolt plate. It gets bolted down. Rail mounting can be mounted to strut channel, can be stacked on top of each other. We have a double weld plate, which would be 2 side by side in the standard series with 4 bolts, and group weld plate, which is a number of clamps sharing a common bottom plate, and we'll go into the detail on all those mounting configurations a little bit later. The hardware that the standard series is offered in is typically zinc plated. So if you don't specify anything else, you're getting a zinc plated cover plate, base plate, bottom plate, weld plate, whatever, and bolts. 304 and 316 stainless steel are also offered. We can even do it untreated. We don't really get many requests for that, but we can do an untreated, just plain carbon steel material. In your insert or your clamp pair, you've got 3 choices, which are polypropylene, sandprene, and aluminum in the standard series. Next, we'll move to the heavy series. Heavy series is and you'll see this slide is very similar. It's just a little bit heavier duty. It has a larger range. Again, it starts at 1/4 inch, but it goes through 8.625 inch OD, which is the OD of an 8-inch pipe. Pressures here we say 5,000/10,000 psi. We'll go over that. There's a heavy series, and we also have what we call our double heavy clamps. It's kind of hard to see, but in the middle, there's a double heavy clamp. You can see, if you can see it, there's 4 bolts in the cover plate. There's actually 2 sets of plastic, and then there's a double weld plate and a double cover plate. So there's 2 sets of plastic in line with the pipe. The pressures for a single heavy up to 5,000, double heavy up to 10,000. Again, it's that general starting point to give you an idea of how to apply it. Your mounting configurations are a little limited, a little more limited in the heavy series. You've got weld, which is the most common. They can be mounted to rails up to a specific size. strut mounted, and also can be stacked on top of one another. Heavy series typically, because it's a heavy duty application, is welded in place. The hardware, the most common or the standard hardware, you can see by looking at it, is just a plain carbon untreated steel. The other options would be 304 stainless steel, 316 stainless steel, and then we even have customers ask us to zinc plate the heavy series, so we do also stock very small quantities of the zinc plated. Insert material here, again, you've got your three choices: polypropylene, santoprene, and aluminum. So here, just wanted to, we kind of touched on it, but I just want to show you a little bit up close. This is the difference between a single heavy and a double heavy clamp. The double heavy, they're double inline pipe. That just gives it that double heavy duty. So that's really the main difference. The cover plate and the weld plate is one single plate. You've got two sets of plastic in there and 4 bolts. So that's the difference between a single heavy and a double heavy. Twin series, again, it's a more of a limit range, 1/4 inch through 1.66 inch OD, which is 1.25 inch pipe. That's the largest size that it goes to in the twin series. It's got a single bolt that holds 2 lines in place. We give it a little bit reduced operating pressure to 1500 psi. We have customers who buy these all the time, large quantities, and use them a lot for 3000 psi systems. So it really depends upon the system, and this is kind of just that, again, general starting point. Twin series clamps are mounted to can be mounted with a weld plate, mounted to a rail, mounted to a strut, and they can be stacked on top of one another. You can see the stacking ones in the back, at the stack here and a stack here, of one on top of another. And we'll go over a little bit more detail how that stacking kit works also, just to get everyone accommodated to that. And the insert materials here, only polypropylene and santoprene. The twin series is not offered with an aluminum clamp pair. Then our Heavy 4 design. Our Heavy 4 is a design that is patented and proprietary to Behringer. It ranges where the Heavy series leaves off at 8-inch pipe or 8.625 and goes all the way up through a 30-inch size. It's very similar in pressures to the Heavy series. We've got a double heavy in the Heavy 4 also, and a single heavy in the Heavy 4. So we've got those same pressure ratings. Only available in weld mounting. If you look at the plates on this, it's significant. They're 1 1/8 bolts. The plates are 1-inch thick steel. You know, the smallest one weighs 100 pounds per clamp. So it's a very heavy-duty design. It's used a lot in the offshore industry, where you've got water injection lines and things like that. So far, the hardware is plain steel, 304 stainless steel. We can do it in 316 stainless steel, have it zinc plated. I don't think we've ever had the request for that, 316 or the zinc plating. The insert material, again, only polypropylene. And if you look at it, this patented design is the 4-segment design. Usually in these large sizes, nobody has this block style type pipe clamp. They use U-bolts. U-bolts allow a clamp to kind of allow a pipe, to slide a little bit. Can cause rubbing and abrasion and things like that. Where this uses the same design as the clamp halves, where they have the ribs inside, but it's in a 4-segment design that really clamps down and secures a pipe and keeps it from moving. I mentioned U-bolts. Again, here's our saddle series. We have what we call a short saddle, and what we have is called a long saddle. Here is what's shown as a long saddle. The saddle kind of sits on this support surface. The U-bolt goes around the pipe and then is bolted in place. That allows the pipe, U-bolts, the pipe will always move a little bit in a U-bolt if there's thermal expansion and contraction, and the saddle actually cushions the pipe from scraping across or sliding across the surface that it's being mounted to. So it helps to protect the pipe. Here we've different materials. The U-bolt and the nuts can be plain steel, 304, 316, zinc plated. All those options are available. The insert here, we've got a few listed. The short saddle, which is not shown, doesn't extend all the way out to where the bolt would go through it. It kind of is a small little saddle that just sits in the middle. It has two locator pins that stick out of the bottom and allow it to kind of, you'd have to drill 2 extra holes and allow it to sit in place. And then that short saddle design, which is not very common, is available in polypropylene only. Then the long saddle, which you're seeing there, is high density polyethylene, is the white material that you're seeing there. We also do it in a cast nylon for high temperatures, and that's a black material. So those are the materials that are offered there. We said you would need to know in clamp selection is the outside diameter. We kind of went over this a little bit, but I'm going to explain your diameter. In this chart, we have what we call our O dimension. That's our space in between, and we put that space in there, as I mentioned earlier, so that when you tighten it down, it really grips and secures that pipe or tube or hose in position. That's where we get our OD of our pipe or our diameter of our clamp. With that O dimension or that gap in there, that's how we would measure our size. So for example, if you look at the chart to the left, a 1/2 inch, you would have to specify if you've got a 1/2 inch pipe or a 1/2 inch tube. And you can see there is a difference. Tubing is rated by its OD. It's 1/2 inch OD tubing, 3/4 inch OD tubing. Whatever size it is, if it's a 1 inch tube, it has a 1 inch OD. Tubing is rated by its outside diameter. Pipe, if you say it's a 1/2 inch pipe, it's a 1/2 inch ID. Then you've got your wall thickness, and the outside diameter of a pipe will be 0.840. It doesn't matter if it's Schedule 40, Schedule 80. It's all got the same standard OD dimension. So it's a nominal inside diameter on a pipe. So a 3/4 pipe, again, would have a 1.05 OD. And those diameters are what our clamp would be measured to, depending on the size. Hose is kind of another animal. Depending on the manufacturer of the hose, the make of the hose, the grade of the hose, they all would have different ODs. You can get a 1/2 inch hose from 5 different manufacturers and have 5 different ODs of that 1/2 inch hose. So hose sizes, we kind of really need to know the exact OD of it, and then we have to find a size that fits, or we would have to make a size that fits. Another thing we mentioned is the mounting configuration. In order to select a clamp, you're going to need to know how it's going to be mounted. If you look at the first one here, we have weld mount. This is the one I'm kind of going around with my pointer right now. The STW, or the number in parentheses, is kind of our abbreviation for that. That's standard weld plate. That weld plate gets tack mounted down to the structure, maybe 2 or 3 or 4 different spots. They tack it down, and then the clamp would get bolted down on top of it. As we mentioned earlier, there's the bolt mount or the base plate. That's our BAP, we call it. Here you'll see that. This one actually has 2 holes. It's an extended weld plate, essentially, with holes so that it can be bolted down. And this is nice for applications where you don't have the ability to weld, or you don't have the surface to weld to. So if you want to mount it to drywall or to wood or something like that, it's very easy to just screw it in or bolt it on that way. Then we've got what we call our double weld mount, and this is in our standard series. We have a double weld, which is almost like a twin series, but a little bit of a heavier duty. Here we've got a common bottom double weld plate that gets welded down, and then there's essentially 2 clamps that mount to it. You would have 2 sets of plastic, 2 cover plates, and 4 bolts in order to mount that down. This is nice because you only have to weld 1 plate down, so it kind of helps for the welding, and it'll keep your strict regimented center distances and keeps everything real clean and tight and nice together. Again, here's an even basically bigger design or longer design, this is what we call our group weld plate. The group weld plate can vary anywhere from 3 positions up to however many positions you can fit in a 4-foot length. We go 4-foot length for the biggest one, and it varies by group size. Obviously, the smaller the group size, the more you can fit in a 4-foot long span. Some of them go up to 27 positions in a group 2, and some of them are around 20 positions and larger. The group weld plate is nice if you've got a customer who uses maybe one that has 4 positions, one that has 5 positions, one that has an 8 position. You can buy the full lengths. You can cut them yourself. They can easily be cut to the length. We stock full lengths here. We can cut them to whatever length you want. You would just order your 3 position, 4 position, 5 position, 10 position, and we can cut them here and send them out that way. So a few more ways the standard series can be mounted. We mentioned rail mounting, and I want to go over this a little bit. This is one that is confusing sometimes. There's 2 different types of rail that we offer. There's the first one here, which is RAL-1. That's our proprietary rail that we designed. There's 2 ways you can mount to it. You see here that this clamp has these rail nuts on the bottom. These rail nuts are very easily put into the rail and then twisted. You can see the design where they've got these stops. So you would turn it sideways, put it in, twist it into place, and it kind of stops there. And then you can bolt your clamp down on top of it. Another nice convenience with this rail and why we designed it is that our weld plates will fit right into that. And so if you don't want to have these rail nuts, the convenience of the rail nut is being able to put it into the middle of the rail. You can put in weld plates, but you have to slide them in from the end. It's actually less expensive to use the weld plate and slide it into the rail. And the weld plate is more versatile. If you're looking at it from a stocking standpoint, you can sell that to people to mount to a rail. They can weld it in place, so they have that option. And even if they mount it to a rail and decide later they want to take it out and weld it down somewhere, they can do that as well. So that's the reason we came up with this rail 1, so that we can just take clamps with weld plates, slide them right in there, and mount them. Rail 0, which you'll see to the right here, this is the standard DIN rail. It's a DIN specification that all our competitors use. So this is the standard rail, I guess, for all of our competitors. The rail nuts have to be used. It's a smaller rail, so if you the width of it is a little bit smaller. If you have a space restriction, that would be the way to go. You have to use these rail nuts. These are our RCN zeros for rail nut zeros down here. These are RCN 1s for rail nut 1s. The RCN 1s go on to rail 1. The RCN zeros go on to rail 0. We try to kind of keep it consistent that way. We've also got adapters for strut channel. These are our UCNs, we call these. These basically are spring-loaded nuts that would pop right into the strut channel. Again, you pop them in, twist, lock them in place, and then you could mount our clamp to a strut channel. It seems that a lot of industrial factories have strut just about everywhere, hanging off the ceiling, off the walls, everywhere. So it's easy if you've already got that and they want to run piping to just adapt our clamp right to it and bolt it right down to the strut that's existing. And then one other thing we'll touch on, and I'm going to go into this in the next slide also, is our stacking kit. The stacking kit, what we say, is it includes everything that you need to take a clamp and bring it one level higher. The stacking kit can be used on any clamp, a clamp with a weld plate, a clamp with rail nuts, a clamp with these rail nuts, strut mounted, with the base plate that we saw earlier. So this basically has these stacking bolts. The stacking bolts have a female thread in the top. The female thread allows a regular bolt to be bolted down into the top of the stacking bolt. The stacking kit also has a safety plate. The safety plate goes in between the 2 halves. Once the stacking bolts are put in, the safety plate actually would go on top and keeps them locked in place from turning. and then your clamp can be bolted on top. And what I'm going to show you here you've got a basic clamp on a weld plate, and excuse the little box around it, but that'll go away in a second. And then here you've got a stacking kit. So you've got your two clamp halves, you've got your safety plate on there, and you've got your bolts, your stacking bolts in there. So the way it works, basically, this clamp you take apart, and then the stacking kit is everything that you would need to put in here. So now this bottom plate can be your weld plate, as in this example. It could also be your rail nuts, or it could be your base plate, or whatever. This bottom plate, doesn't matter what it is. You take your clamp apart, your stacking kit, you slide in below it, you mount your stacking kit down, your bolts, your safety plate goes over top of it. Now this safety plate keeps these bolts from turning. They're tight, everything's tightened down here. Now you put the rest of your original clamp back down on top of it. And so that's how you make your stack of two. So in fast motion, and I don't know how the video is coming across, if it's fluid or smooth or not, but that's kind of how you would mount it together. That's always a question, and so that's why I went over that in a little bit more detail. That's the standard series. Those are all the options in a standard series. We said the heavy series was a little bit limited. I'll go over this quickly because we kind of described it already. You've got a weld mount, again, in the heavy series, most common way, and the double weld mount, or the double heavy clamp, is welded down also. It shows a breakout where you've got the double heavy with the bolts and the single plate, the single bottom plate, and then the two sets of plastic. Stacking kit, again, it works the same way in the heavy series. It's a little bit different of a design in the stacking bolts, but it's the same thing. Rail mounted. Now in our heavy series, we do the same thing as in our standard series. This is the standard DIN rail with the rail nuts. The clamp mounts right to it. To make things easier, we've got also a rail 2 and a rail 3. Rail 2 allows you to take groups, it says here, H3 through H5, and mount them on the rail 2 with the weld plate, like in the standard series. And then our H6 group can be mounted to the rail 3. Above that, you can't mount to a rail with a weld plate. Twin series, we'll go over this again real quick because it's all the same type of things we just learned about. You've got the weld mounted, you've got a rail mounted. Again, we do the same thing. You've got a rail 0. That's the standard series rail 0. Same rail 0 from the standard series. With this rail nut, this clamp can mount right to it. That's the standard DIN rail that all our competitors use. Again, it's the same rail as the standard series. The rail nut's a little bit different for the twin, but it adapts it to the same rail. Strut mounting, again, it can mount to a unistrut. And here we do the same thing. Here's our rail 1. With the twin series, you can use the same RCN. It's actually an RCN, not 1, we call it a 4 for the twin series, but it mounts to that same rail 1, or the weld plate from the twin series can slide into the rail 1. So you do have that flexibility with that rail 1. And then also stacking kit. It's very similar, but the safety locking plate is just a small square that fits inside a recessed area in the plastic, and that's what locks the bolt from turning. Heavy 4 series, there's only two ways you can mount it. You can, well, there's only one way you can mount it. You can weld it. There's two different designs. We've got our single and our double heavy, just like in the regular heavy series, the heavy 4 series, again being 4 quadrants of plastic, but really only one way to mount it, and that's to weld it in place. Our saddle series, now here we talked about the long saddle and the short saddle before. The long saddle is mounted with 2 holes drilled through your surface, and the saddle sits on top and the bolts go through the surface. The short saddle here, you can see it doesn't extend over to the bolts. It's basically just like a little shoe. It has these locator pins on the bottom. You would drill holes in your surface so that this would sit there and the saddle won't slide. That's what keeps that saddle in place. And then you would have your holes out here to mount your U-bolt. This is not very common because of that fact that you have to drill 2 extra holes. If you've already got U-bolt holes, these are standard pipe size U-bolts that you might use everywhere. It's real easy to just add a saddle. Here you've got to drill extra holes. It takes more time. So it's not really the most common way of mounting it. We also mentioned during clamp selection you need to know the threads. UNC is always our standard. If you want metric, you can request that. We can do the metric thread bolts and weld plates. It may affect the price depending on which one it is. Typically the standard series, it doesn't affect the price. Heavy series, some larger sizes, we don't typically stock the metric components, so it might be something that would change the price a little bit. So you'd have to consult the factory on that. And it's always on metric good to give us a call just to make sure that we have it in stock, because a lot of it is kind of touch and go on that. And then the last thing that we had mentioned as far as selecting a clamp that you'll need to know is any type of environmental factors or environmental requirements that the customer might have. Temperature is going to be the most determining factor of the clamp pair selection. So your two clamp halves, polypropylene, santoprene, or aluminum, depending on the temperature, that's what's going to really affect why you select one of those. Water, the presence of any type of water, whether it's rain, whether it's ocean, whether it's lake, spray, anything like that, washdown, may determine whether or not you want to use 304 or 316 hardware. 304 stainless steel is good for outdoors or where it's going to see contact with water. 316 stainless steel, we would typically say, is recommended for any type of application where it's going to come in contact with salt water or there's any type of salt concentration in the air. It's a higher grade of stainless steel. It's used a lot in washdown areas. The next item is chemicals. So if you've got an area that's cleaned with some sort of caustic material that may require that you use 316 stainless steel, it might just be a preference. A customer wants 316 stainless steel, or it might be in a food and dairy application. They might require 304 or require 316. And then another determining factor would be the application. If it's in a high impact area, if there's excessive vibration, if it's underwater, extreme operating conditions, anything like that, you should take into consideration what the environment is like, where this clamp is going to be, and that might help you determine anything from hardware materials or whether you're going to go with a standard or a heavy series. It even helps with spacing, and we'll kind of go over the recommended spacings and things like that in a little bit too. So those are kind of the main points that you will need to know in order to select a clamp. Once you've got all that stuff, you can go back and we can, if you want, just request that we email you this presentation in a PDF. We can send it out to you. You can use this as your rule of thumb or your guide to go through and look at it and say, okay, here's my checklist. We'll go a little bit over installation too. I want to touch on these four key requirements or key checkpoints, I guess, for installation or a checklist. We'll go over each one in detail. Spacing, we have recommended spacing charts to use. We've got a new catalog that we're working on. It's very close to being complete. I know our current catalog is a little bit confusing. All of these things are going to be in our new catalog. The recommended spacing, as it says, would be in the new catalog. We also have it now available as a sheet in a PDF, and it's basically just a dimension from the center of one clamp to the center of the next. That's your recommended spacing, and it goes by your OD size. So the way it looks is if you've got a OD from 1/4 inch to, say, 3/8, your recommended spacing should be every 5 to 7 feet. That's kind of the way it would look and the way it does look. I didn't put it all here because it's a big chart and it would be difficult to read in a presentation, but we can get those to you, and it's something that everyone should really have on hand, because when the customer is always going to ask, how many do I buy, Where do I put them? Another thing to take into consideration is going to be what we call torque end load. We have another chart, again, recommended values for the torque of the bolts, how tight you should tighten those bolts, and that'll tell you at that tightening torque the recommended force. You can see the arrow here, the force on this pipe in pounds required to actually cause slippage. And at that point, that's where this pipe would actually start to slide. And usually, well, always, the value required to actually cause that pipe to slide is way higher than anything that pipe is ever going to be holding or weighing, in most situations, I'll say, because I don't want to say in every. But it's also going to be in the new catalog. We also have it in a PDF. We can send it to you, and that's what that shear force would be in order to create that pipe to slide. And if spaced properly, that will never happen. Another important thing to take into consideration when putting together a bill of materials of what you're going to need for your system or your customer's system is any bends and corners or components, anything that's in the system. You should always put your clamp as close to each side of any type of bend or component as possible. This helps create, obviously, as you know, a bend in any type of system is an area where you've got a lot of stress, where you've got fluid coming around a corner. It's pushing, it's pulling, it creates vibration and shock. It creates some water hammer and things like that. The bend is always the part that gets the brunt of all that force. So as close to the bend as possible. If there's any connectors on the pipe or any welds, you should put it immediately after that. As soon as the pipe becomes straight, that's where your clamp should be. If you can't get that close, and it's as close as you can get it as possible. Same thing with any type of valves, any type of filters, or any type of other type of sensitive component in the system. It should be supported on either side with a pipe clamp. This reduces the vibration and noise or anything like that component is going to see. So that's going to extend the life of your component by supporting it that way. If there's any questions there, we can stop and answer some questions. I think most people have been typing them in the chat box, which works well. Adam's been answering your questions as we go, so I think we'll continue on. The last part of the presentation, and this is not going to take very long, I just want to go over some different industry applications for our clamps, and we'll go over just really 4 general industries and maybe some kind of more specifics in each industry. Mobile equipment is by far the most common application for our pipe clamps, and it's as a distributor, it's a very lucrative business, or a very lucrative application for our clamps. If you look at any of these types of equipment, anything that has a hydraulic system on it in agriculture, in mining, off-highway, construction, any type of piece of large equipment, even small equipment, there's a lot of hoses, there's a lot of piping, there's a lot of tubing. Hydraulics are driving that whole machine, and there's clamps everywhere. So a lot of OEMs too that build this machinery use a massive amount of clamps. They use a lot of clamps on one machine, and they're constantly putting out new machines. So I think the industrial or the mobile equipment is one area where we can be really successful. Any one of these OEMs would be a good target account for pipe clamps, and it's usually a pretty large dollar volume of pipe clamps that they use in a year. Any industrial manufacturing facility will have pipes, pipe clamps, anything like that. Steel and primary metals, you can see from this picture here, there's hydraulic systems. They've got a billet machine there. The steel, the billet is extremely hot. The hydraulic systems anywhere near or around that need to have secure piping. and that piping typically is using aluminum inserts for the pipe clamps. The steel industry kind of uses the aluminum clamp pairs just about anywhere in the facility, just as a standard. That's what they do. Even if it's not directly or near the hot areas, it tends to be the preference to use aluminum everywhere. The semiconductor industry, our clamps are used a lot in any type of piping or even cables, any type of conduit and things like that, because the plastic, the polypropylene and the santoprene act as an insulator, and so the piping will be completely insulated from the support structure that it's welded to or bolted to. And this is very important in the semiconductor industry because it eliminates any type of static electricity or electrical discharge from the pipe or the tube to the support structure and other equipment. And that's very important because they can destroy any type of product that they're manufacturing if there's electrical, static electricity or any type of discharge. Machining centers, you can look down at this picture and see there's kind of piping and cables and conduit and tubing run everywhere. You've got machines all throughout a shop like this that have, a lot of times there's a central coolant system, and you've got coolant running from to each machine and back, and there's sumps, and they all run to, and then they run back to a system, central system, and any of these electrical cables and plumbing or anything like that in between all need to be supported. You can see kind of stuff hanging all over the ceiling. That would be most likely unistrut or strut channel, and clamps can easily adapt to strut channel. That's typically what you'll find inside of an industrial manufacturing facility, and you can easily bolt our pipes right, bolt our clamps right to those channels. And the last application here, chemical and process industry. That's there's any type of chemical industry or process industry. There's piping everywhere. I'm sure most of you have been to some sort of a process facility or chemical facility and seen the piping running everywhere. There's a lot of saddle clamps. There's a lot of strut channels, so a lot of our strut clamps can be used there, and even our standard and heavy series clamps. So there's a lot of opportunity there. A lot of the process and chemical industry, there's not a lot of vibration and shock in the large pipes that they have running around outside. So that's a good application for our saddle series. A lot of in the internal stuff and smaller lines can be cushion clamps and even our block style small standard series. The last two sections, one is offshore platforms. We'll go over that kind of briefly. If it's not your industry, you know, it might not have much use for you, but these offshore platforms, a lot of times are built, the components of them anyway, are built by different OEMs spread out around the country, and are not specific to a region. Any type of system on these has piping, and because they're out at sea and most of these production platforms are floating, there's a lot of movement, there's a lot of vibration. They've got hydraulic control systems, they've got ballast water systems, they pump water injection and mud pumps and things like that, processed water, even potable water and drinking water and things like that. And then FPSO vessels, I mean, if you've got customers that build these types of equipment, this would probably be more specifically around Louisiana, Texas area in the United States. This is kind of, if you look at the deck of this vessel, there's just piping everywhere. There's process plants everywhere. They have compressor systems, big, large water injection systems that inject water down through the bottom of the ocean floor in order to force the oil out. So here there's a lot of different you know, applications and a lot of different specific applications that come from different areas around the country that are building all these little components that will actually get shipped to the shipyards to build these things. And not only these industrial ships, but also cruise lines and, you know, commercial vessels and things like that will use a lot of pipes. It really, anywhere that you have pipes, you can use pipe clamps. So there's really a lot of different applications. That kind of concludes the applications that I had prepared. That also kind of concludes the presentation. I hope that I didn't go too fast. I wanted to kind of get everything done within an hour and show everyone kind of a general overview of what's available and what we can do. If there's any questions, we can take those now. There's one more thing I do want to show you, and this is just kind of for future webinars and things like that. From our website, and I'll show that to you here. I can pop that open for you. This is our website or our home page. You've got all our different product groups listed on here, industrial pipe clamps, and then you've got all these other ones. One thing I just want to point out to everyone is that you'll see it up here. You can click here or even over here is our online training button. We're offering these webinars. We've got future ones planned. We do one a month on a different product. Here on our website you can see, obviously this is today. After today, this one will be gone. This will be the first one. Our next presentation will be on our moly filter product line, also our sanitary product line, and then we're going to update and add some more courses. Now, the courses that we have here are our basic introduction courses. Second half of the year, we're going to be more technical, more detail-oriented applications, more detail-oriented on the product and things like that. So you can click any one of these links. We've got 2 times offered for each one. Eastern time, we've got an 8 and an 11 o'clock to try to accommodate people on the East and West Coast. And you can, just from our website, you're able to click on any one of these links to register for those webinars. One other thing, too, at the top, you'll see previously recorded webinars. If you click on that link, it'll show you some of the webinars that we've had already. And you can view those at any time. You can have your customer view them or anything like that. In the future, you can click on those. You could download them, or you could launch them in a Windows Media Player, and you'll be able to watch those presentations. So that concludes the presentation for today. I appreciate your time. I appreciate you coming out. Before you go, if anyone has any questions or anything like that, you can still type them in the chat, and we'll answer them. We'll leave it open for another 10 minutes or so. If you have any requests, type it in there also. If you'd like a copy of the literature, or if you'd like a copy of the presentation in a PDF form or anything like that, just let us know. Now it looks like there's a hand raised. Let me see if, yeah, but there's not a question there. So with that, I'll conclude it. As I said, just feel free to type in any remarks or anything like that. After you log out from the webinar, there's also an exit survey. Just kind of helps us gauge how well we did. So if you could kind of take maybe a minute and fill that survey out for us, we would appreciate that. So thank you very much, and I hope to see you all in the next presentation. Take care. Bye-bye.